less than 5 solar mass, pulsar में finish होगा. But if its mass is more than 5 times of our sun mass, it will end up into black hole. So there is no connection between that star and the sun, but Chandrasekhar take it. Actually, Chandrasekhar followed a one concept of electron degeneracy. Let me write over here, electron degeneracy concept. Actually, we taught it into the higher physics, MSc physics or higher level physics, electron degeneracy concept. I hope all of you are aware about the basic structure of the atom. Like there is a nucleus and around it electrons revolve. That is structure of atom. So there is a positive charge in the nucleus, you know. There is a negative charge. So this positive is attracting the negative charge. If anyhow the mass of nucleus get more than 1.4, then it is called as electron degeneracy concept. So if mass is more than 1.4 times of its mass, then at that time the electron will fall into the nucleus. So only nucleus will left. Where electron goes, enter into nucleus. There is a positive charge in the nucleus, negative in electron, they cancel each other. So it will become neutral. But density of nucleus get increased up. And size decrease. Like this pan. If nucleus is left into this pan, it will become very minute but very dense. Same thing happens. That's why the name is neutron star. Only neutrons are left. Electron, they fall into the nucleus. So electron, proton, they cancel each other. Only neutron are left. So neutron star is a very dense star of very small size. But white dwarf, it is a star which releases visible light. Visible light. Our sun is presently releasing all sort of light. Short wave, visible, long wave, gamma to X-rays to UV to Vibgyor, infra, radio, AM, FM, all type of rays. But white dwarf release visible light. So it appear white in color. So there is a possibility with the neutron star, it will convert into pulsar. So pulsar are fast rotating. So they spin very fastly on their axis. Spin fastly on axis. So by spinning fastly on their axis, they release electromagnetic waves. Release EM. पूरा लिखें आप लोग. Write it completely. Electromagnetic waves, especially radio waves. So radio waves are released mostly from them. So we can intercept these radio waves. So communication can be possible. Right? NISAR. ISRO has launched one satellite, NISAR. NISAR. ISRO will launch NISAR 2 in 2025. So this is NASA ISRO synthetic aperture radar. It is space satellite which will intercept the radio waves coming from pulsars. Right? Then black hole. Black hole is some substance from where light does not emit out. So it is very highly dense. Light is not able to pass through it. That's why it is not visible at all. So that is overall the story of our star. So our sun will also end up one day into these things. Did you get it? Presently our sun is here. It is in the mature star. Only 25% fuel of it is burnt. Once its complete fuel will burn, then it will enter into red giant stage. From there it will blast into supernova. Then our Subramanyam Chandrasekhar will be applicable. Okay. So very interesting story of Subramanyam Chandrasekhar and Albert Einstein that gives a new dimensions to the astrophysics. In fact, astrophysics branch started when Subramanyam Chandrasekhar meet with Albert Einstein. But in geography, we will not go into the details of the astrophysics. We are restricting ourselves to this part. What is our Earth? So we say our Earth is a planet. So we'll come to that. What is planet? Of solar system. That's why we understand solar system. It is sun and its family. So we are dealing with sun properly. Then we will come to its family. Sun is a star of Milky Way galaxy. So we deal with the galaxy properly here. What is galaxy? How it is different from constellation? We specially deal with our Mandakini galaxy. Milky Way is a part of it. From there, we understand the North Pole, celestial North Pole, celestial South Pole of Earth. Right? Now we are here on the sun. As we come on the sun, that's why we deal with a little bit the cycle of star, but come back on the sun. So this is the composition of our sun. Okay, now come to the structure of the sun. There are three layers identified in the sun. The innermost layer is called as photosphere. Then it is surrounded by chemosphere, chromosphere, chromosphere. Outermost layer is called as corona. Corona means crown, coronavirus, crown like shape. So it is the outermost part, corona. Recently, last year, ISRO has launched a mission Aditya L1, Lagrange point 1. Aditya is for sun study. So objective is to study this corona chromosphere. So photosphere is the innermost part. Chromosphere middle, corona outside. So as you see the sun, the visible part is photosphere. We cannot see them. But during eclipse, solar eclipse, a small ring is appeared outside, that is chromosphere and corona. The belief is this: the innermost part, photosphere, over it the nuclear fusion reaction is taking place. So it is a source of light, and its innermost part, core. There are the news these days, a one satellite of NASA, Solar Parker probe, has do its flyby mission, second last flyby mission from sun, fly nearby. So in 2026 or 27, it will touch the photosphere. Already it has become a first object which is nearest to the sun. So by their data, we have understand that the temperature of photosphere is 5,000 to 6,000 degrees Celsius. Although it is measured in Kelvin, Kelvin is SI unit, but we are measuring it in degrees Celsius. So that is a temperature of photosphere. But temperature of chromosphere is 2 to 3 lakh degrees Celsius. And temperature of corona, outermost part, it is 5 to 6 lakh degrees Celsius. So opposite of our belief, thank you. Opposite of our belief. The source has less temperature, but temperature increases outside. Actually, here heat dynamics come into role. Thermodynamics principles are applicable. You should know how heat is transferred. There are three ways by which heat is transferred. Like this is a candle. You can do it practically. This is a candle. If so, it is having a flame. So it is very easy to pass your hand from the flame. You can do it practically. But can you put your hand little bit above the flame? बच्चे क्वेश्चन भी पूछ रहे हैं क्या? ये पूछ रहे हैं ना? Okay. So that is flame. But if you put your hand just above the flame, it is not possible. Because in the flame, heat is transferred only by conduction process. But as you are above, heat is transferred by convection and radiation also. These are three ways by which heat can be transferred from source to other object. Slowly in climatology, oceanography, what are these things that will be covered? So in photosphere only conduction is taking place, but just above it, radiation, convection, they plays role and temperature increases. All right, dear. So that is structure of sun. Okay. So over sun, see what happens over our sun. This is sun. So it is releasing the light, or you can say heat. So hydrogen is converting into helium. Helium atom. Did you know the structure of helium atom? Helium atomic number is 2, mass number is 4. Let's make it structure. Basic physics. So there is a nucleus. Inside nucleus, 2 atomic number means 2 proton. 4 mass number means proton plus neutron. So there should be 2 neutron. 0 indicate neutron. So now total number is 4. 4 ho gaya. Outer side, shell. In this shell or energy level, electrons are moving. So as there is no charge over it, so means positive negative is equal, so neutral. So only two electrons are floating. That is helium, right? Understanding is very important. We will not explore this area at a one point. We will slowly come into this. I mean, there are many related concepts with it. We'll discuss it when time will come. Because this year in the mains UPSC, there is a question, what are auroras? So for that also this topic is relevant. We'll come back. Okay. So if you supply energy to it, energy like this pan hit this blackboard. This is energy, bombardment, or simply warm it. So provide energy in form of heat. Warm it, garam karo ise, like this pan. If you warm it, what do you think? Where that energy goes? Directly into nucleus or in the outer part? If it is very high energy, it can cross the nucleus and cross the bars of these orbits and can directly go into nucleus. This is nuclear reaction. In nuclear reaction, energy directly goes to the nucleus. But like this pan, if you supply a less energy to it, so first outer shell will burn, then inner part will burn. Same thing happens here. So if you heat it, the energy goes to electron, right? Now, electrons, they are revolving in a particular energy level. So if they get the energy, they jump. This is called excitation of electron. They jump, they come back. This is de-excitation. We'll discuss it separately also, but let's consider it as a good energy. So electrons, they get energy and now move away. If you become energetic, so you can run, right? So they get energy and they get run away. So it also get run away. Now it is so energetic, so high, it is not in reach of positive charge. So it is away from the attraction of positive charge. This is called as release of atom. It is also called as ionization. Technically, this process is also called as ionization, formation of ions. So if two electrons are gone away, what happens with helium? It became He2 positive. Only nucleus is left. Electrons move away. Right? You know, this He2 positive is also called as alpha particle. It is also called as alpha particle. It means nucleus of helium. Only positive charge is left. Same thing happens in the sun. In the sun, our hydrogen is converting into helium by fusion reaction, and temperature is very high. At that high temperature, how you can expect that helium structure will not break? It undergoes breaking. Electrons are released and alpha particle is formed. Right? So there is accumulation of alpha particle, charged particle, He2 positive in short you can say. And what happens with this electron? It is moved away. Dear, in basic physics of your 9th standard, 10th standard, you have read one chapter, electromagnetism. What is moving electron? It is called as charge or current, right? So same thing happens with sun. So there is a light, heat is released, electron is released. So at electron is released, it is a current which is released from sun. Current is moving from sun. Huge current is released from the sun in all directions. Whenever current moves, it produces magnetic field also. It is actually called as Hun's law. H-A-N-S, Hun's law. Read your school days books. It was proposed by Austin Hun's. It is called as Hun's law. He says that moving current to produce magnetic field. So along with sun, along with this electric current, magnetic field is also released from sun. Understand? Magnetic field is released. Did you get it? So sun is a source of current. Sun is a source of magnetic field. It comes into universe. It hit the earth also. It hit the earth also. We'll study it in atmospheric layers of earth. But at some time, what happened? The alpha particle, like suppose this is one area where lot of alpha particle get accumulated. Positive charge is accumulated here. So this extra positive charge, if accumulated at one place, it stops the release of light and heat from this place. So this place appear black. You can do one thing, wear the goggles, sunglasses and observe the sun next day, you will see some black spots on the sun surface. These black spots are due to extra accumulation of these alpha particles. So these black spots are called as sunspot, also called as faculae. In Latin, we call these black spots as sunspot, these sunspots as faculae. So these are areas where charged particle, positive charged particle is accumulated. Did you get it? Sometime if lot of pressure is built up below them, then by force, these charged particles are thrown away. This is called a solar flare. So it's like a heat is thrown up into the space, solar flare. Also called as coronal mass ejection. Coronal mass ejection. Eject means away. Mass means mass, weight. So it is a mass of alpha which is thrown away into the space. As it comes from outer part, so it is coronal mass ejection. If it goes into space, coronal mass ejection, lot of heat is thrown into the space. So planets, they will receive the slap of the heat, like Earth is there. Here is the Earth. So if this heat come and hit the Earth, so due to this heat, it is like a slapping of a heat on the Earth. So temperature of Earth also get increased up. Okay, but sometime as it jump away, the gravity of sun pulls them back. So jump away pulls them back. So it is just like a loop of the flare that is formed, right? Looping loops. So this loop rise up and then goes back. This is basically called as flare loop of sun. Sometime the release of these electrons and alpha particle increase from sun. Actually, this phenomena, if these alpha particles and electrons, their release get increased up, it is also called as a magnetic storm, simply called a solar storm. Like 2-3 months back, magnetic storm hit the earth. They are responsible for increased auroras on the earth, right? So topics are interrelated, but we will left this topic for the climatology part. There we will understand what is aurora, because for that there is a need to understand the structuring of the atmosphere, composition of atmosphere. All right, done there. So this is basic understanding of sun. This is our sun. Now there is a family of sun. So family does mean those celestial bodies which are under the gravitational pull of sun. So due to that gravitational pull, they are revolving around the sun. Okay. So come to now family of sun. So in the family, those bodies which revolves around the sun due to its gravity. So as they are under the gravitational impact of the sun, so they revolve around the sun. Like say this is sun. Some object is here, so it is revolving. Some is here, it is revolving. All of them constitute sun family. So who come into sun family? Many celestial bodies. Actually, the system now, the laptop is far away from me. I prefer the interactive classes. It should be a dialogue. But I cannot see from here your answers, but you should know what comes under the family of sun. क्या क्या आते हैं? Planets. They come. What else? Satellites. What else? Asteroid. Dwarf planet. Comet. Meteor. Meteorite. Right? They are under the family of the sun. So, what are planets? Our Earth is a planet. Now we are on this question. So we come back on this question. Where is that? This Earth is a planet of the solar system. So we will deal entire the family. For that, first part is the planet. So we are here. Planet. Earth is a planet. So how many planets are there? Many of you will give answer 8. Someone among you may give answer 9. Because in your school days, in your childhood days, it was a common understanding that there are 9 planets in solar system. But these days you are reading these, there are 8 planets. So why 8 now? Why 9 earlier? Actually, it is a Pluto which make a difference. Right? So Pluto is no more planet. That's why there are 8. Why it is not planet now? Earlier it was planet. Is it a will of Pluto? Now became planet. Now I don't want to become planet, so let me put into the other category. No, no, no. There is a criteria. There is a one organization, IAU, International Astronomical Union. Right? So International Astronomical Union, it has put 3 criterias. See, listen it carefully, it is important. 3 criterias. One is object should revolve around sun. That is one criteria. Right? Object should have spherical shape. Actually, IAU use a word hydrostatic balance. Hydro means water. They use this word hydrostatic balance. Hydro means water. Static means stable. So if one drop of water is stable, what is its shape? Spherical shape. So we have a common understanding this hydrostatic balance means spherical shape, but nearby spherical shape. Not perfect spherical, like Earth is not perfect spherical, but nearby spherical. Correct? What is hydrostatic balance? But like a spherical. Third is object should have clear orbit. These are 3 criteria. If any celestial body who satisfy all these 3 criteria, like see what is it? One is object should revolve around sun. So this is sun. Let's take Earth. This is Earth. So is Earth is revolving around the sun? Yes. So Earth satisfies first criteria. Is Earth is spherical? By and large, so Earth satisfies second criteria. Does Earth has a clear orbit? What is Earth? Orbit. This is orbit. The path in which it is revolving. Clear means there should not be no other object in this orbit. Like if some object comes in front of Earth, that is not a clear orbit. No, no, no. This orbit should be clear. No one is there. So this orbit belongs to Earth only. So Earth satisfies third also. It is a planet. So those who satisfy these 3, they are called as planet. But those who satisfy first 2 only, they are called as dwarf planet. So dwarf planet don't satisfy third criteria. Those who satisfy only first criteria, this one, not second, not third, they are called as asteroid. Asteroid or asteroid? Roid is simple, roid is plural. So simple. So if all these 3 green colors, we have covered all 3 boxes, that is planet. Red cover, we have enclosed 2, first one. In that box, we have enclosed first 2 points. So red is dwarf planet. This object is revolving, object is a spherical shape, but object does not have clear orbit. And in the pink, only the first, not second, not third. Object is revolving, don't have spherical shape, don't have clear orbit. That is asteroid. Like imagine, this is some sun, this is some object of triangular shape. It is revolving. So it satisfies first. Don't have spherical shape, not satisfy second. There are some other objects in front of it. So orbit is also not clear. So it is asteroid. Right? But if someone is spherical here, so it is revolving, satisfy first. It is spherical, satisfy second. In front of it, some other comes. So not third, but it is a dwarf planet now. Understand? So that is the meaning of planet, asteroid, dwarf planet. See now the Pluto. What is the interesting case with the Pluto? I hope all these things are written. Okay. Now see the interesting case with Pluto. There is Sun in the middle part. So let's make the planets. Who is the first one? M for Mercury. Who is the second one? V for Venus. Third, Earth. Fourth, M again Mars. Then beyond Mars, there are some stones of different shape floating. One of them is spherical. This belt is called as asteroid belt. Right? Beyond asteroid belt, we have another planet. What is this? Jupiter. Then Saturn. Then Uranus. Then Neptune. Look at it, this one. This is Pluto, spherical in shape, but look at its revolution. This way it revolves, cut across the orbit of Neptune, and then it became flat again. This is Pluto. Okay, so in this asteroid belt, one object is spherical. It is Ceres. It is a dwarf planet. Pluto, it is a dwarf planet. One is Meres, M-E-R-E-S, that is nearby it. That is also dwarf. So Pluto, its orbit is not clear. See, it cut across the orbit of Neptune. Actually, it is tilted orbit, so Neptune is in orbit. But due to tiltation, Pluto enters into the orbit of Neptune. So other are revolving like this way. Pluto is little bit tilted. By tiltation, it enters into Neptune. So for 30 days, it remains inside the Neptune orbit. So the revolution time period of Pluto is nearby 242 years. So for 30 years, it remains into this orbit. So in 1988, it enters into orbit of Neptune. 30 years means in 2018, it comes out. So in 1998, our telescopes were not so developed. So by looking or observing the movement of Pluto, International Astronomical Union has observed in 2005 that Pluto has already entered into orbit of Neptune. So immediately in 2005, they put Pluto into the category of dwarf planet. So it has already entered in 1988, but we come to know in 2005. So in 2005, it was put into the category of dwarf planet. So planet became 8 in number, but in 2018, it comes out. And for next 200 years, see, its orbit is clear. Now it is not in the orbit of other one. So there is a proposal into the IAU to put Pluto again into the category of planet. That proposal is under consideration. Okay, if that proposal will be accepted, then again there will be 9 planets for next 200 years. This is IAU criteria. Right? But still that is not accepted. So Pluto is under a dwarf category. Technically it has come out. So technically it is a planet, but not officially accepted yet. But there is a chance that in the next meeting of IAU, it will be accepted in 2025 itself. This proposal was introduced in 2020. It, due to COVID, it was not taken seriously in 21, 22, 23. In 25, again a new meeting will be held, and in that meeting, it is chance that this proposal could be accepted. Then again, we will have 9 planets. Presently, 8. So these are asteroids. They are also revolving, but orbit is not clear, shape is not clear. Shape of the one of them is spherical. Okay. Now, beyond this Neptune, in this zone, Pluto is in this zone. Some dust, stones, gases, these are also floating. So sometime this zone beyond Neptune, Pluto is in this zone. It is called as Kuiper belt beyond Neptune. So this one is Kuiper belt. So it is written as Kuiper, but pronounce it Kuiper after name of a scientist, Kuiper. So it is area beyond Neptune. Beyond Neptune. And it is composed of some stones, frozen ammonia. What is NH3? Ammonia. Frozen CH4 means methane. So their combination is revolving around the sun. That area is called as Kuiper. So these gases are here, stones are here, frozen ammonia, methane is here. By this revolution, sometimes they come close to each other. Like they form a mass here. As they come here, they get collected to form a big unit here. Now, as of their mass, they get attracted sharply toward the sun. So by cutting across the orbit of all planets, they move like this way to the sun. That is called as comet. So actually it is a tadpole structure, head-tail structure. So there is a head, this is tail. Like one comet is passing in month of February from Earth. You can see into the sky. Delhi mein to dikhega hi nahi. So if you are in a remote area away from Delhi or metropolitan cities, you can see there is a comet that will be visible for 10-12 days in month of February in the sky. So these things, they get collected at a one place to form a one mass. That mass vertically, very important thing. So other planets are revolving horizontally. They move vertically like this way, cutting across orbit of all. So there is a chance of collision of them to the planet. Like Earth is revolving this way. One comet come and hit the Earth. Maybe. Like Earth is coming from there, comes here. Comet is moving this way and hit the Earth. One such asteroid, or you can say comet, hit the Earth during the Cretaceous time period. We will understand what is Cretaceous, but at that time, roughly 65-70 million years before, at that time dinosaurs dies. So it could be catastrophic. Like one famous comet is Halley comet. Halley is a meteorologist. Halley comet, 76-year time period of revolution. So they are called as comets. So comet is made up of them. They have a head-tail structure. So their frontal part is towards sun, that is head. Backward rear part is a gas, elongated gas structure, that is tail. So once in UPSC prelims, this question is hard. Consider following statements about comet. So they have a head is towards sun. Second statement, they have a tail is a long elongated gas and away from sun. So simple. Even a logic, basic logic can explain this, right? Sometimes we feel very bad that we study so hard and UPSC asks such pity questions, right? But they are tricky even. So from the basic geography part, many questions come. This is astronomy only. Okay, beyond Kuiper belt, what lies? There is one more zone that is called as Oort cloud. So this is sun. Say this is the outermost part of Kuiper belt. Say this is Kuiper belt. Even John. Within the Kuiper belt, our comets are formed. Pluto is here. Outside Kuiper belt, this big John. Big John is there. This is called as OORT, Oort cloud. Oort cloud is only combination of gases. No stone, no ammonia, no methane. Gases float. Majorly hydrogen, helium, carbon, oxygen. These gases are also under the rotation because sun gravity lies to this part. This is the outermost limit of sun. Beyond sun, this area is called as interstellar part or zone. एक मूवी भी है इंटरस्टेलर, STELLER, ये E है. Okay. So that is sun and the parts of its family. So here we deal with planets, satellites which revolve around planet, asteroid, dwarf planet, comet. There is one more term here. Go back. In the family, I think I have rubbed that. So in the family, what else come? Okay, that is rubbed. In the family of the sun, meteorites are also there. So let's see what are meteor, what are meteorite. Meteorite. In Hindi, comet is called as पुच्छल तारा, जिसके पूछ होती है, पुच्छल तारा. Not तारा, but technically not तारा, but Hindi terminologies are like this. Meteor, it is called as Ulkasha. Meteorite, it is called as Ulka Pind. So see, what does it mean? Suppose there is your Earth. This is surface of Earth. You know, around Earth there is an atmosphere, gases. Due to the gravity of Earth, suppose some stone get attracted towards Earth from asteroid belt to somewhere else. This is some, say, asteroid. That get attracted towards Earth. Or simply say stone, no need to write asteroid. The stone may come from anywhere, but by gravity of Earth, it is pulled into the Earth. As it enters into the atmosphere of Earth, what happens? There is a friction between gases and stone. Yes or no? Like this way. I release this pan in the air. So there is a friction between pan and the air. So what happens with friction? Like you keep on rubbing your hand, you will feel warmness. Heat is created. Same thing. When it enters due to friction, heat is created. So with heat, it starts burning now. Burning. This phenomena is called as shooting star. In Hindi, we called it Tutta Hua Tara. But it is not star or Tara. So it is phenomena, you can say. Phenomena of burning. Burning of meteor is our shooting star. Now there are two possibilities with this stone. One is by burning it may burn completely. So it could be 1 kg, 2 kg, small half kg, few gram. It may burn completely. Like you have seen sometime in the sky one star fall down. That is not star that is falling down. That is shooting star actually. So as they burn, so they get lighted up and they get appeared from visible naked eyes. So if two possibilities, one they get completely burned. Second is they after burning some part of them reach to the surface. Like they are big 10 kg. So 8 kg burn, 2 kg stone fall down. So if they get completely burned into atmosphere, then they are called as meteor. But if they landed, reaches on the surface, then they are called as meteorite. So meteor, shooting star, which burns completely in atmosphere, they are called as meteor. But shooting star, which reaches to surface, they are called as meteorite. All right, dear. So shooting star, which burns, that is meteor, which reaches, that is meteorite. So this is basic understanding of our astronomy, part of geography. So our Earth is a planet. Now from here onward, we will restrict ourselves to the planet. Earth पर रहेंगे आप. Is it done? When we will come to geomorphology properly, there we will understand the formation of universe, Earth. There are theories we will understand in geomorphology, but it is basic geography only. Okay, now on the Earth, maximum page. Okay, so let's rub it. We are on Earth, so we have understand Earth is a planet. So from here onward, we will stick to the Earth. So first of all, let's start from shape of Earth. What is shape of Earth? Shape of Earth is Geoid. It is not perfectly spherical. It is not elliptical. It is not oval. It is geoid in shape. Now you might be thinking that what is geoid? Geo means earth. A shape which resembles the shape of earth is geoid shape. So dear, actually it is not a mathematical figure. Like I says you, shape of earth is circular. Circular is a mathematical figure. Spherical, three-dimensional mathematical figure. Triangular, mathematical figure. Square, rectangular, na? Pentagon, these are mathematical figures. So actually it is not a separate mathematical figure. This figure come into existence after the name of the shape of the earth. So what is geoid? It is actually a oblongated sphere. Oblongated sphere. What does it mean? Oblongated, obliquely pull the sphere. Obliquely pull sphere. Obliquely means horizontal, you can say. Horizontally pull the sphere. Like say this is sphere. So there are two ways by which you can pull it. Like say this bottle, I can pull it by this way towards this side. I can pull it this way. If this pull vertical, if this sideward pull, it is horizontal. So you can pull it vertically up and down. This is vertical pull. But if you pull it sideward side, it is horizontal pull. So pull it horizontally, not vertically. So horizontal pull means pull it like this way. So sphere has a center. This is C. So if you pull it horizontally, its shape undergoes change. Like imagine a rubber ball, rubber football. You pull it like this way. So it get extended into the middle part, but from upper and downward part, it get little bit indented. Same thing happen. So it became flat from top and bottom, moves downward. This is center. In middle part, it gets slightly extended outward. This way. Slightly extended outward. If you pull it like this way. This is called a geoid shape. So in the geoid shape, it is flat from top and bottom, extended outward in the middle, or you can say bulge in middle. So in the middle part, it is having a bulge. So still it has the same radius like in the sphere R. Say R, capital R. R is same everywhere. Still it has the same radius. Answer is no. Due to this pull, the upper downward part come close to center. This middle part goes away. So now this is the upper radius R1, but this is the middle radius from this C center R2. So the central part of the radius is more as compared to the vertical part, right? So definitely in the geoid, this situation occur R2 more than R1. So what is R2? Central radius is more than vertical radius. Central radius exceeds vertical radius. This is geoid shape. So it is flat from upper part to lower part, slightly flat. In the middle part, it is extended outward. Earth is of this shape. So is this shape has some impact? Yes. It has some physical impact. Okay, now come to this part. Effect of shape of Earth. See, what are the effects? In fact, as effects, kya effects? So it has multiple effects. The first one, should I rub this part or should I move to next page? लिखो write it first. Same thing. Let's rub this part. Effect of Earth shape. See, first effect. First effect is on gravity. So is gravity same everywhere over Earth? Answer is no. So first effect is variation of gravity. What is gravity? Is a force as per the Newton definition. So Newton proposed force is directly proportional to m1 multiplied by m2, inversely proportional to square of distance between object. Like suppose here is a one object A that is placed. So if you want to calculate the gravity between A and this spherical object, so spherical object mass is concentrated here at C, right? So A and this center C are attracting each other. So you can put this A anywhere. R radius is same at all places. So gravity of A, gravity over the A from C is same everywhere because it is dependent, force is dependent upon R. How dependent? Inversely. F is inversely dependent upon R means radius, or you can say distance from center. What is radius? Distance from this center. So is it same now? No, 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 no. It is less here, more here. So if it is less, gravity should be more because inverse. So if this R is less, gravity should be more. If this R is more, gravity should be less. So that is variation of gravity. What we can say? More gravity at top and bottom. You will understand, actually we called them poles. What are poles? We will understand it. Terminology is understood later on, but you should know the basic thing. The upper lower part is called as poles. Less gravity at middle part. Middle part. You will understand this is called as equator. So less gravity at equator. No, equator poles. Technically understand them later when we will discuss latitude, longitude. So less gravity at middle part, more at top bottom, that is poles. Okay. So that is the first effect of the shape. Second effect. I have a question. Is your weight is same everywhere on the earth? Means you measure your weight in Kolkata, Delhi, Chennai, Srinagar, Moscow, Australia. Will it remain same? No, weight is changeable. So that is second effect. So let me write here. Second effect. Variation of weight of object. What is weight? Physics में how we define weight? Weight is equal to m into g, mass into gravity. So this gravity itself is variable, so weight should vary. Although on an average we take it 9.8, but it is variable, more here, less here. So as it is variable, weight should vary. So wherever it is more, weight should more, because g is directly proportional to w. Where g is more, weight should be more. Where g is more, poles. Where it is less, gravity, equator. So simple logic is weight is more at poles, less at equator. So if you measure your weight in Delhi, suppose your weight is 70, but if you go to Moscow and then measure your weight, it could increase by 71, 70.5. But if you go in Chennai and then measure your weight, will decrease because you are closer to equator now. So weight variation. Second. Third effect. Come to third effect. So first is variation of gravity, second is variation of weight, third effect. Variation of temperature. Temperature, we will understand it properly in climatology. What is temperature? How it is measured? We will discuss that properly, but here basically we have to understand. See, this is shape of earth. Okay? There is sun. From sun, sun rays are coming. Sun rays are coming. Sun rays are coming. So don't you think sun rays has to travel less distance to reach at this middle part? Yes or no? Less distance here, more distance here, further more distance at the poles. So sun is a source of heat. Sun to kya hai? Source of heat. So if you are closer to the source of heat, like this wall is firing, there is a fire. If I am close, I will receive more heat. If I am away, I will receive less heat. Practical thing. So this part is closer to the sun, so more heat. Less heat, least heat. Right? So that is variation of temperature. More heat in middle, less heat, less temperature, you can say, in polar region. Okay, so that is impact. ओहो, नेट बंद हो गया क्या? क्या हुआ? नेट बंद हो गया? नहीं चल रहा. आई होप आप देख रहे होंगे, ठीक है ना? सो मोर हीट इन द मिडिल, लेस हीट इन द पोलर रीजन. That is variation of temperature. So these are the three effect of the shape. Shape के three effect है. Okay. Three effect of the shape. Now over this geoid earth, dear, we have drawn some imaginary lines. So we have to discuss that only. आगे चले, next topic. Imaginary lines over earth. Imaginary lines over earth. So these are imaginary, not naturally present, not practically present, but we have drawn them. So man do everything for some convenience, right? I'm teaching, doing it for some convenience. You are studying, doing it for some convenience. Man do things for the convenience. So we make these lines for convenience. So man has drawn two type of lines on the earth for the convenience. One are horizontal lines. Horizontal lines, or you can say circles. In 2 dimension it is line, or in 3 dimension it is circle. Like this bottle. So if you make a one circle over it, it is circle. But if you see it from top, take a picture of it from mobile, it will comes out to be a line only. So say it line or circle, same thing. Second is vertical lines or circles. So simple. This is earth. This is earth. Extended outward little bit in middle. So draw such type of circles from backward side this way. Draw such type of circle from back. You can imagine this way. So such type of circles, right? These are horizontal, but vertical. This is earth. So how vertically? This way. This way. Many circles this way. These are vertical circles. Okay, this way, vertical circles. We called these horizontal lines or circles as latitudes. These are called as latitudes or parallels. But this vertical, we called them longitudes or meridians. Okay. So these are latitudes or parallels. These are longitudes or meridians. So let's handle them one by one. Latitudes. And then we will come to these longitudes. So first, latitudes. Latitudes or parallels. So these are horizontal lines. So make Earth. See, this is Earth. Not perfectly sphere, just but for a while take it sphere. This is center. So exactly over the center, make a one line this way. So it is above the center. Like this bottle. This you strip, it is exactly over the center. As they accept this strip. Right? Here like this way. So if you now cut the earth from this line, so a plane will be formed, like you have cut it, like cut it this way. So it's not, it is a plane. So plane, a plane, one plane is formed. Do you think that that center point lies on this plane? Obviously comes. If you cut it, chop it from here, the center points will come on this plane. So what is the angle between that central point or this plane? What is the angle between this center and this plane? 0 degree. 0 degree, because it is on it. So it's 0 degree. So let's make a 0 degree angle here. Okay. We called this line or circle in two-dimensional line, but it is circle. We called this line or circle as a equator. थोड़ा देर 10 मिनट. इस ऊपर सारा काम आज ही करेंगे क्या? Okay, equator 0 degree. So dear, don't you think this circle or line divide this sphere, means earth, into two equal halves? Yes or no? You have a watermelon. If you cut it from here, is it divide it into two equal parts? Yes. Any imaginary circle which divides earth into two equal halves is called as a great circle. So equator is a great circle. It divides earth into two equal halves. Sphere. Half of sphere is hemisphere. So hemi means half. So this upper one is called as northern hemisphere. This lower one is called as southern hemisphere. So equator is a great circle. Is it so? Now dear, draw other circles in both northern and southern hemisphere. Like draw a one circle here, this way, 3-dimension from the backward side. Like let me draw this. Dotted line means from back side, this way, back side, a one circle, right? So now let me rub this dotted line. So this is one circle. One circle. It is making, say, some angle. Like if you calculate this angle, say it comes 1 degree. So we will call it now 1 degree N. N means north. Okay. If you draw other circle like this way, suppose this is making 2 degree angle. This angle is 2 degree. So we'll call it 2 degree north. So on. 3 degree, 4 degree. Say this one. If you calculate this angle from center of earth, say this angle is 30 degree. 30 degree. So you will call it 30 degree N. So on. Suppose if you draw this circle, it is making this 60 degree angle. So we'll call it 60 degree N. This one, some angle say 70 degree N. What about this point northernmost? How much angle this point or this circle will make? 90 degree. Is not so? So we'll call it 90 degree N. N means north. So this way 1 degree and 2 degree and 3 degree and so on. 1, 2, 3, 4. So with the difference of 1, we can make how much circles there, lines there? 1, 2, 3, 4, 5, 6, 90. 90 there. Same thing in the south. There is other circle. It is making 1 degree angle with center, 1 degree S. It is making, say, 10 degree angle with center, so 10 degree S. Say it is making 30 degree angle with center, so 30 degree S. S indicates south. 60 degree angle with center, 60 degree south. What about this point? Is not, it is making a 90 degree angle, so call it 90S. Here, this 90N is called as geographic North Pole. This 90s, this is called a geographic south pole. Okay, so we have geographical north pole, geographical south pole, and equator. I have a question. Is this 30-degree and is dividing earth into two equal parts? No, can't divide kar rahi. This is upper part, small level is below. 10 degree, 60 degree, 90 degree, 10 degree south, 20 degree south. Are other latitudes dividing earth into two equal halves? Answer is no. So all latitudes are not great circle. Only equator is a great circle. Other latitudes are not great circle. हो गया बस 5-7 मिनट 10 मिनट. Only equator is a great circle. Other are not. Do you get it? So first tell me how many total latitudes. Why we call them parallels? Because they are parallel to each other. They don't intersect. They are parallel to each other. Isn't it? And the distance between two latitudes, like 1 degree and 2 degree and there is certain distance between them. This distance between them is 111.11 kilometer. 111 kilometer, 11 meter. So we take it 111 only. Like 2 degree and 3 degree and distance is same. 3 degree, 4 degree distance is this. 50 degree, 51 degree, 111 kilometer distance. Is that it? So see certain properties of latitudes. So make a heading. Properties of latitudes. Number 1. They are, what is this symbol in mathematics? Parallel. Parallel to each other. So they are parallel to each other. So parallel means they don't intersect each other. They don't cut each other. Second, they are equidistant from each other. And what is distance between them? 111 kilometer. So they are equally situated away from each other. 111 kilometer. Okay. Third, total number of latitudes. How many total latitudes are there? Calculate them. 1, 2, 3, 4 up to 19 one side, 19 second side, 180. What about 0? 181. So total number of latitude is 181. 90 north, 90 south plus 0. But if someone asks you how many circles of latitude, ये तो total number of latitude हो गए. If someone asks you circles of latitude, how many such circles? So 0 is a circle. 1, 2, 9, 89. Is this 90 is a circle? No, it is a dot. It is dot. It is dot. It is dot. So it is not a line. Line, you cannot show it in a line form. So total is 181 minus this, minus 2. So it will come 181 minus 2. So total 179. So total number is 181, but lines or circles, if someone asks you, that is 179. Because 90 and 90s, they are dot only. They are not circle, not line. Okay, dear. Look at it. Only equator is a great circle, others are not. Some of the latitudes are famous one. So how they are famous? For that we have to understand one more property. Fifth, there are two latitudes, like say this is one latitude, say 15 degree north. This is other latitude, say 14 degree north. Between them we can make further parallel lines, yes or no? Yes, we can make. So we divide degree into minutes. So 1 degree is divided into 1 degree, you can say degree, is divided into 60 minutes. Like 1 hour is divided into minute. So it is just a nomenclature. So these middle lines we are calling them minute. You can say them X, Y, Z, whatever name. But geographers call them minute. Geographers minute bolte hain. So 1 over 1 degree ke andar 60 small lines can be made. Like if it will be, and what is the symbol of minute? Degree is represented by this one, and minute is represented by this slash hyphen. So it is 1 degree, 10th line, 1, 2, 3, 4, 5, 5th line. So we'll represent it 1 degree, 5 minute n. This slash, this indicate n, minute. So if exactly in the middle part, so it will be called 14 degree, 30 minute n. 30 means half. Okay. So that is the 5th point. Write down, please write down 5th one. 1 degree is divided into 60 minutes. 1 degree is divided into 60 minutes. 60 minutes में divided है. Whole idea. Okay. Now come to some famous latitudes. Some famous latitudes. Okay, see, this is Earth. This is center. So one is above the center. 0 degree. We call it equator. One famous latitude is here. So dot means from the backward side, like this way. It is making 23 degree 30 minute north. 30 means half. Half again. So we can write it like this way as well. 23.5 degree and north. We call this line as a Tropic of Cancer. Similarly, this one. Dot means from the backward side. It is making 66 and 30 minutes. So we can write it 66.5 degree north. This circle is called as Arctic Circle. This 90 degree north, we called it Geographic North Pole, or commonly called as North Pole. But remember, I told you there are various type of pole. Like one we have discussed celestial poles. It is Geographic North Pole. North Pole, इसी को बोल देते. We called it as a North Pole commonly, but it is Geographic North Pole. Technically, right word is Geographical North Pole. There is Magnetic North Pole also. Geomagnetic बोलते हैं जिसको. Same thing in the south. This is one circle. Dotted line means from the backward side of Earth. It is also making 23.5 degree S now. South. We called this line as a Tropic of Capricorn. Then this one is 66.5 degree S. We called it Antarctic Circle. This one is 90 degree S. We called it South Pole. Famous latitudes. So here is a question: why 23.5 degree north, 66? What is the logic behind it? Actually, logic is tiltation of Earth. Logic is tiltation of Earth. All right. Logic is tiltation of Earth. Let's see that. Write it quickly. This is 0 degree equator, 23.5 degree north, Tropic of Cancer, 66.5 degree north, Arctic Circle, 90 degree north, North Pole, 23.5 degree south, Tropic of Capricorn, 66.5 degree south, Antarctic Circle, 90 degrees South Pole. Alright here. Now why 23.5? The logic is tiltation of Earth. Earth actually is not straight, it is tilted. So we can make even imaginary line that is axis. So there is a issue called as axis of Earth. The last part here, then we will discuss in next lecture. What is axis? Say this is center of Earth. Earth is a three-dimensional sphere. Like say this bottle, a football. So inside the football there is center. So if we pass an imaginary line this way, passing through center, like this way, this one. So this line is called as axis. So how we defined it? A imaginary line joining North Pole, South Pole and center. So passing through center, that is called as axis. So it is a again imaginary line joining north pole, south pole and center of earth. So it is passing through inside earth, like this is a line. So this is north pole, south pole. So this is axis of earth. So in geoid shape, how it appears? Like this way. This way. So center, this axis of earth. Axis. So issue is our earth is not straight on its axis. It is straight. It is tilted. Other planets are also tilted. Some are more, some are less. Right? Some more, some less. Mars is also tilted, same as that of the earth. Both labor similar. They are tilted. Mercury is straight. But some planets are more tilted, some are less. What could be the reason? No one knows. But we believe it is due to the gravitational pull towards more one side. Right? So see. Now make it tiltedly pulled. So I'm rubbing it. So how tilted? Like this is the north now, this is the south now. This is north, this is south, this is center. So extended outward into the middle. So see, this way it is tilted. Now this is the axis of earth. So this is NP north pole, this is SP south pole. So had it been straight, it should be like this way, but it is tilted, it is this way. So we can calculate this angle. Had it been straight and this angle, it is presently tilted and straight. This angle we can calculate, right? So what is this angle? You know, had it been straight, so this angle of tiltation is 23.4 degree. Really it is 23.4, but we take it 23.5, round off the figure. So 23.5 degree tilt. 5 मान के इसको half ले लेते. So from horizontal axis this much it is tilted. So we can calculate it from this vertical axis also. So if it is 23 and 4, so what should be this one? So 23 and half है तो ये कितना बच गया? 66 and half, because it should be 90 minus 23 and half, 66 and half degree tilt. This is tiltation of earth. That's why we have taken a tropic of Cancer. That's why we have taken a tropic of Capricorn. So what is the real location of our latitude lines? This way. This is earth. This is tilted earth. This way. This is equator. This is the real position here. This is equator, 0 degree. This is tropic of Cancer, 23.5 degree north. This is tropic of Capricorn, 66.5 degree north. This is North Pole. Similarly, this is 23.5 degrees south, tropic of Capricorn. This is 66.5 degrees south, Antarctic Circle, South Pole, and this is axis of Earth. They are tilted. All are tilted. That's it. This is latitude. Okay. So in next lecture we will continue with the longitude, and come some other topics of basic geography. Before coming to the properly physical geography, they need to understand this physical. So that is for today. Thank you, dear one. So we are ending the session now.
Sir, students, आज का क्लास कैसा था?
Sir, अच्छा
How today's class?
Sir, this is highly helpful, sir.
Anything else you want to say, or you want to add to it, so that anything else you want to add to it, or you want just to leave now? Sure. Thank you.